So the Lionheart Linton and Barnstable locos with factory fitted sound use a Zimo sound chip, and buried within the coding of the chip are a couple of Lenz innovations. So Lenz has been very influential in DCC. They helped write the original language, and they've developed a number of features for DCC that some manufacturers have taken up. So the first feature we're going to look at is bidirectional communication using RailCom. Very technical sounding name, but basically allows the decoder to talk back to your control system if your control system has RailCom. So the first thing I'm going to look at is the driving properties of the loco as set from the factory. You can see that the acceleration delay is quite long. Takes a long time for it to get up to speed, even though I've put the throttle right up. And similarly, the braking deceleration delay is quite long as well. It takes a long time to stop. So, rather than putting it on the programming track and finding out what those features are, I'm able to do that on the main. So using the RailCom system, I can go into programming on main. I can look at CV3, which is acceleration delay, and read it. Got a high value, 60. Now I've written down the factory set so I can put the loco back. But what I'm going to do is turn this to a much lower value. I'm going to put a value of 10 in. And similar with the braking delay in CV4. It's up at 35. Clear that and put it down to 8. Escape. So let's see what the result is now for driving. Now the loco is much more directly controllable from the throttle. Still accelerates quite smoothly, but it is getting up to a higher speed quicker. Getting up to speed quicker, put that way, and stopping quicker. It's very useful, obviously, if you've got a very tiny layout. And let's be honest, 016.5 is designed for small layouts. Let's have a quick look at that with the sound. As you can hear, it accelerates up nicely and decelerates equally nicely now. At any time I can put it back to the factory accelerations, there's no problem there. Let's turn that off for the second. So we're going to have a look at another of the hidden Lenz innovations that are in that chip. You may notice some blue wires. They go off to a Lenz BM1 ABC braking module, which is a diode matrix. What this is doing is dropping the voltage to one of the rails, and you can see here I've put a gap in the rails. For best practice you'd put an insulated rail joiner in, but for this demonstration I've just notched the rail so that it's broken, and so that the power comes through this module. So from the Zimo instructions I know that CV27 controls ABC braking. So we go in, programming on main, CV number 27, and read it. It's at 0, so nothing's selected. If I write in a value of 2, it will tell the loco to turn on ABC braking with the voltage drop on the right hand rail. So it's quite subtle. Let's actually do it with sound, it's more effective. Up she goes up to speed. I'm not touching the throttle. When she gets past the gap, the last wheel will have to get past the gap because we've got pickups on the last wheel. And there you are, she's stopping automatically. Leave the throttle visible so I'm not messing around with it. What I can do is bridge the gap. You'd put a switch in the circuit, so I'm just being... Oops, find the gap. There we are. So I've put main power to the track and it cuts out the ABC braking. So you can have a switch on this circuit that switches out this module and allows normal power to get to the rail. So you've got a stop and go section, and you can combine that switch with the signal. So the other good thing about ABC braking is it's directional. So I've set it so it's on the right hand rail in forward direction, or in direction of travel I should say. It will allow you to back the loco out of the section. So there we are, there's a couple of things that are buried in the decoder that perhaps wouldn't have been noticed. So having a look in the Lionheart instruction manual, they've got this thing called Realdrive. So we're going to use that RailCom programming on the main to make the changes it says in the instructions. So to activate the Realdrive, what you're doing is setting CV4 up to its maximum value, 254. And as you've seen earlier in the video, CV4 is the deceleration delay. So putting it up to a massive value means that it's going to take forever to decelerate. And the other part of the Realdrive is to turn on a brake function. So what we're doing in the second half of that is setting CV309 to a value of 7, which means that function 7 becomes the brake button. So what it does is override the acceleration delay in 254. In CV4, sorry, and decelerates much faster. So let's have a go with that. I'm going to put the sound on again because it's part of the thing. So we'll go into that programming on main, CV4, your deceleration delay. So from the factory it was on 35, although it says 27 in the manual. It's kind of arbitrary. Let's put it up to the 254 it says, which is the maximum. And escape, and then CV309 to allocate the function there to value 7. I've been playing around with this before, so I obviously left it on 7 by accident. Right. Let me take us back to the start of the track, so I've got a bit of room. So again, I've put it on factory set acceleration, so it's quite slow to accelerate. We close the throttle. You'll see it now coasts on very, very slowly. Bring the brake in to stop it. I've got it on a permanent function switch. You can, it says in the manual, put it to momentary to sort of keep pressing the button to stop the loco. I think once you've decided to stop, you stop. Right, so let's go forward. Open her up. Again, we've got quite an acceleration delay on this. I think it was 60 from the factory. Close the throttle, and you see it coasts on. We've got a nice coasting beat on the decoder as well. Now activate the brake. Now we'll bring it to a halt. And it's nicely turning the page on the manual for me. Thing with Realdrive is if you leave the brake on, the loco will not move. So once I've released the brake, now she will start driving. So that's more or less Realdrive. You have got to remember to use the brake to bring the loco to a halt. So personally I think it's something that if you've got larger room on your layouts, better runoffs, then you're less likely to have the loco run away with you. So yeah, you do need to use the brake to stop it, otherwise it will coast on forever. Well, eventually it will stop, but it'll be a long time. So that was Realdrive, and we will look at turning Realdrive off. So we'll do the opposite of what we had set. So into the programming on main, CV4, it was on 35, so I will clear it and overwrite with 35, escape, and that's CV309, it's on 7, clear it, overwrite it with 0, and this time press the button to send it. So now we've gone back to the conventional driving. So it'll decelerate a bit better and it will stop according to the lower value in CV4. So that just gives you an idea of the usefulness of this RailCom, the ability to read the decoder out on the layout. We call it global RailCom. And obviously we had a look at the ABC braking, which is nice for signal sections if you want to do it.